Okay, folks, we're back live. Yes, okay. Right, that's lovely. Thank you. Okay. Right, that's lovely, nice and big. Question number 14. Represent this inequality on the number line. N is greater than -2. So we use an empty circle, meaning that's not part of the solution. So it's going to be everything to this side for the moment. Okay, so here n is greater than -2, but n must also be less than or equal to 3. Because it's equal to, it must be a solid black. Okay, so it's going to be a number more than -2, but less than 3. So what happens is these two parts will join together. And that's our solution. Done. Solve the inequality. Ifra, how do we solve the inequality? The way we solve it, like any double-sided linear equation, we treat the inequality sign as though it was an equal sign for the moment. Okay, can you just check that the image is straight? Yeah? Are we okay? Good. Okay, now, just answer. Whenever you solve the double-sided equations, okay, we always start with the smaller x value first. So we start at the 6x, we move the 6x towards the 8x. So 6x goes from the left to the, right to the left. So plus 6x becomes
-6x.
And if you move the x's to the left, the numbers must move to the
right.
So -3 must go that way. Opposite of -3 on this side becomes on that side. So you have on this side now 8x minus 6x. We have +4 +3. Okay, Mr. Staff, are you copying these things down? Good, well done. 8x minus 6x is 2x. 4 add 3 will give us
7.
Okay, don't worry now that the 7 is not a multiple of 2, that's not a problem. Okay, opposite of time by 2 is?
Divided by 2.
So 7 divided by 2 is?
3.5.
3.5, 3.5. Okay. That question is done. So let's quickly, everybody done that, let's move on to the next bit.
Yeah.
So I'm looking for one. Next question please folks. Samia.
I think it's false.
Okay, that's lovely. Can you make that one question a bit bigger? That's excellent. Question number 15. One sheet of paper is 9 times by 10 to the -3 centimeters thick. Mark wants to put 500 sheets of paper into this tray. The paper tray is only 4 centimeters deep. Is the paper tray deep enough for the 500 sheets? You must explain your answer. So you can't say stuff like the answer is yes or no because I know it is. Yeah, that won't cut any mustard on the examiner. So let's have a look. We've got 500 sheets. And each sheet is 9 times by 10 to the -3. Okay, that's the calculation that we need to do first of all. So, 500 times by 9, let's do this part first. 500 times by 9. 500 times by 9 will give us? 4,500. Okay, time by 10 to the -3. What does that mean by time by 10 to the -3? When you have 10 to the -3, it means that this number here, if you decimalize it, you have to divide it by 10,000. So 1, 2, 3. The -3 means move back 3 places for that number. So the answer becomes 4.5 centimeters. And so the answer is no. The tray is not deep enough. Okay, it's not deep enough. It is half a centimeter short. So we need a corner half centimeter, but it's only 4 centimeters. Okay? So we explain that. Let's move on to the next question, folks. Copy that down.
Yeah.
Okay, we need to be quick time so we can try to finish this paper off. Question number 16, beautiful, nice and big, I like that. That's it. The normal price of a television is reduced by 30% in a sale. Now, let's quick question. Let's have Rutaba. What's the normal price of a TV? Normal price. When you go to shop TV, normal price is called how much percent? 100%. So the normal price was 100%. It's been reduced by 30%. So how much is it worth now? 70%. So the sale price is. So we can say now that the £350 is equivalent to 70%. Are we happy with that, folks?
Yeah.
So that sale price is now worth 70% of the original value because they're not 30% off. What we need to do now is work backwards from 70% to 100%. So how do we get from 70% to 100%? First we'll go from 70 to, if you want to do it like in 2 quick steps, 70 down to 10 and then 10 up to 100. Excellent. So now how do we get from 70 to 10?
Divided by 7.
How do we get from 10 to 100?
Divided by 10.
Okay, that's just a way for us to think about it. It's non-calculated paper, so we don't want to be busting ourselves up with any dividing by decimals. So 70 divided by 7 is 10, 10 down by 10 is 100%. Now, 350. What you do on the right, you do on the left. 350 divided by 7 is, folks?
50.
50. And then 50 times by 10 is?
500.
500. So the original price of the normal price of the TV was? £500. Okay, folks, let's move on to the next question. Please, give me the next question. Come on. Folks, you got all that down?
Yeah.
Yes? Oh, this is my favorite question. Oh, lovely question here. Yummy, yummy. Right, okay. Question number 17. Ideally, we want to be on that side of the board, but anyway, I'm going to have to do what we have it on. Just change colours. Okay. Move the question that way.
This way?
That way.
That way?
That way, a bit more.
That's it, that's all it goes.
Okay, that's fine. Take it up a bit. So meter the pond in the shape of a prism, question number 17. We have the height of the 1.3 meters, half a meter at the shorter end, 2 meters wide, sorry, 2 meters long, 1 meter wide. Okay? The pond is completely full of water, so Meet wants to empty the pond so he can clean it. So Meet uses the pump to empty the pond. The volume of water in the pond decreases at a constant rate. The level of the water in the pond goes down by 20 centimeters in the first 30 minutes. That's very important. So let's work that out first. So we lose 20 centimeters, which is how much of a meter? How much of a meter? 20 centimeters? 0.2 meters, which is that divided by 100. That's how much we lost in the first, how much time?
Half an hour.
Half an hour. It's taken half an hour to go down to that level. So what we're going to do now, we're going to work out the volume of the water that's actually been drained out in the half an hour. So this shape here, Ramiz, look. This shape here, that's like the 3D shape which I've drawn, is called a cuboid. Thank you, Ramiz. So we have a cuboid. The volume of a cuboid is? Length
times width times height.
So this is going to give us the volume of
Cuboid.
this cuboid of liquid that's come out. It's volume of liquid. So the length of this is
2.
2. And the width is, what's the width?
1.
1.
And what's the height?
20.
0.2.
0.2. Okay, folks, this is where students make mistakes. They've got meters and you've gone down by 20 centimeters. 2 different units. Make the units consistent. So we can work in meters. Do not use 20 here. Do not use 20 centimeters because these are all meters. So you must use 0.2. So then, Umar, are you happy with that?
Yeah.
Because that's meters, that's meters, and that's meters. You can't go from meters to centimeters. You'll make the question wrong. So, 2 times by 1, folks, is?
2.
And 2 times by 0.2 is?
2.2.
Okay, so the volume is equal to 0.4 meters cubed per half hour. So 0.2 times by 2 gives us 0.4. That's how we've lost 0.4 meters cubed of volume in half an hour. So how much have we lost in a full hour?
0.8.
If we are losing, Rutaba, 0.4 meters cubed per every half an hour, how much are we losing per hour? What do we just do with that number? We double the number to work out what the hourly rate is at the same rate. So in 1 hour we will lose 0.8 meters per cube. That's our flow rate, constant. Okay? Now, okay, goes there. Next question on the bottom says here now, that's the first part of the question. We worked out how much volume is lost, we worked out the flow rate. Now the question goes, work out how much more time Sumit has to wait for the pump to empty the pond completely. So this was the important part, to work out how much water was lost. We know how much time. We worked out then the hourly rate of water lost. Now we need to work out how much water is left and how long that will take to pump out. Okay, now, Mr. Umar,
Yeah.
this height was originally, how big was the height?
1.3.
1.3, and we lost how much?
0.3.
So how much is left over now?
1.1.
1.1. Okay, let's have Afira, Ifra. Ifra, the original height is 0.5 at the shallow end, and then we lost 0.2 meters. So how much is left over?
0.3.
0.3. So we have to adjust the values on the table, no, on the diagram. Now, okay, next question. Prataba, this original length here, has that changed? No. So this is still 2 meters long, yeah? Are you happy with that? Now we need to work out the volume of this. What kind of shape is this in me? It is called a trapezoid, because it's a trapezium but in 3D. Right, what I'm going to do now, I'm going to rub off the top part so we don't get the two things confused. I'm going to rub off this part for the moment. Okay, so I'm now going to focus on okay, we're going to focus on this trapezium and then its thickness. The thickness is 1 meter. Now, if you want to work out the volume of a 3D shape, let's start doing some rules for that now. So the volume of a prism is equal to the area of the face, I call it, times by the thickness of the shape. That's one way of looking at it. Now the area of the face, this face, here's the face here. The face is here. This is the face. Now the face is a trapezium. Who knows the formula for the area of a trapezium? The area of a trapezium is, don't all shout at once.
A plus 2 5 by 2 times 6.
Thank you, Samira. Okay, at least I know something I can read in the class. Okay.
What does times
A plus B divided by 2 times by the height.
the top? So you
Thickness.
Area of face times by thickness. Yeah, happy with that?
Yeah.
And the thickness here, the thickness is 1 meter. Done. Now, let's start putting in some of the values in. What I'm going to do, I'm going to actually rub the letters out, start putting the values in. So for those of you following us at home, please do yours, work slide down. I'm running out of space. Let's see, maybe what I call. So the A and the B are the two parallel sides. So I'm going to call this one A. I'm going to call this one B. So we can do here 1.1 for A, add 0.3 for B, divided by 2, times it by the height. What's the height of the trapezium this way? The height is this way. That one, that's the height. 2 meters. I know it looks like a length, but it's just the way the trapezium is turned around. If these are parallel sides, then that is the height, regardless of its orientation in this picture. Okay? Okay, we're happy with that, Hamza? Put all the values in now. So 1.1 add 0.3 is 1.1 add 0.3 is
1.4.
1.4. 1.4 divided by 2 is
0.7.
0.7. Then 0.7. Then time by 2 is back to 1.4. And then 1.4 time by 1 is still 1.4. So these two in a sense will cancel each other out. So we end up with 1.4 meters cubed. 1.4 meters cubed worth of volume left. Now, here comes the last part. We haven't finished yet, folks. I know it sounds like, looks like a long question. So how many marks is that question?
6.
6 marks, folks. This is 6 mark question in the examination. They want you to sweat a bit, at least. If you're not sweating, then you haven't done enough work. So 1.4 meters cubed in the bottom part, Hamza, yes? You have to drain it out at what rate? 0.8 meters per hour, yeah? So now we have to say, here's the last part of the calculation. Just change colour. So we got 1.4, we have to divide it by 0.8. So we do 1.4 meters cubed. It's flowing out at 0.8 meters cubed per hour. We've got to work that out. Okay, 1.4 divided by 0.8. Still over here. When you divide it by a decimal, okay, we can do it 2 different ways. We can turn this into a fraction, turn that into a fraction, or we can just turn this into a whole number and do the bus stop method. So 0.8, we've got to turn it into a whole number by multiplying by 10. So I need to turn this number into a whole number. So if I times this by 10, I have to times.
Not by 10.
So the question gets transformed into 14 divided by 8. That's how we deal with decimal division. To convert the number that we're dividing by into a whole number, and whatever we do to this number, we do that number. So we got 14 divided by 8. It's okay? 2 minutes left. So the 8 goes at the front, and the 14 goes in here. Right. So, how many 8s goes into 1 is? You can't fit 8 into 1, so you have the 1 left over. How many 8s go into 14 will be? 1.
6.
Okay, and remainder 6. Thank you. So how many 8s go into 60?
7.
8 times by 7 is?
56.
Okay. Remainder 4. Put another 0 down. How many 8s in 40?
5.
5.
Okay, 1 second. Let's just. $1.75 hours. Now, before you go any further with this question, you think you're finished. When you give to answer in time, do you ever say to your parents, I'll be back in 1.75 hours?
No.
No. If you say that, your parents will look at you, what are you talking about? 1.75. We don't do decimal time in that sense. They must convert into minutes. So, Mr. Saf, 0.75 is how much as a fraction? 0.75 is?
3/4.
3/4. So 1.75 is 1 and 3/4 hours. That's okay as an answer. 1 3/4 hours, or 1 hour and 45 minutes, and so on and so on. But we shouldn't give the answer in decimal. That's not good. Okay, folks, are we happy with that long question? Hamza? Okay? Okay, folks, I'm afraid that's how much work you do for that question. Okay, Smee, can you give us the next question, please?
Sorry.
Okay, yeah, okay. Yeah.